We consider the equation r equals 3. It is written with polar coordinates, and we want to convert the equation into rectangular coordinates. We will draw the graph r equals 3 first. We mark a point in the middle, we call it the pole, and then we draw the polar axis. The equation r equals 3 means no matter what the angle is, the directed distance from the pole is always 3. So we have the point 3, 0, and then another point 3 pi over 6, and then another point 3 pi over 3, and so on. We draw many points. After we draw sufficient points, we join the points with a smooth line. It looks like a circle. We will also do the conversion using algebraic method. We will square the equation r equals 3 to get r squared equals 3 squared. From the theorem in the book, we know r squared is the same as x squared plus y squared. Then we have our answer, x squared plus y squared equals 3 squared. We look at the graph. The graph is a circle centered at the origin with radius 3, which agrees with the answer. So our answer is correct. We consider the equation theta equals pi over 3. We will convert it into rectangular coordinates. We first sketch the graph. We draw the pole and then the polar axes with scale 1, 2, and 3. The equation theta equals pi over 3 means the measure of rotation from the polar axis is always pi over 3, no matter what the directed distance from the pole is. So it doesn't matter what r is, the angle is always pi over 3. So we have the point 1 pi over 3, 2 pi over 3, and so on. After we draw a few points, we will join them together with a smooth line. It looks like a straight line. We will solve this algebraically. We treat theta and pi over 3 as the argument of the tangent function. We get tangent of theta equals tangent of pi over 3. And pi over 3 is a common angle. Tangent of pi over 3 is square root of 3. We use the theorem in the book. It says as far as x is non-zero, tangent of theta equals y over x. And then we multiply both sides by x to get y equals square root of 3 times x. We will consider the case when x equals 0. We look at this equation we got. When x equals 0, the right side is 0, so y equals 0. So we have to look at the original equation and see if the point 0, 0 is in there. Now we look at the graph. The pole is on the graph. We can have a point 0, pi over 3. That's the pole. Then the origin correspondingly in the rectangular coordinates 0, 0 is also on the graph. That means our equation y equals square root of 3 times x is our answer. We will convert the equation r equals 3 cosine of theta into rectangular coordinates. We first multiply both sides of the equation by r. We get r squared equals 3r cosine of theta. R cosine of theta is the same as x, so we have 3x on the right, and r squared is the same as x squared plus y squared. We subtract 3x from both sides of the equation. We get x squared minus 3x plus y squared equals 0. We complete the square. We use the absolute value of the coefficient of x, which is 3 divided by 2, and then we square this fraction. We add to both sides of the equation. So we add 3 over 2 squared to both sides of the equation. Our answer is x minus 3 over 2 squared plus y squared equals 3 over 2 all squared. From this equation, we know it's a circle centered at 3 halves, 0, with radius 3 halves. We will check our answer by going to wolframalpha.com. We type in plot r equals 3 cosine of theta. And we see that this is a circle. The diameter is 3, that means the radius is 1.5 or 3 halves. The center is 3 halves, 0. That means our answer is correct. We convert the equation r equals negative 3 secant of theta into polar coordinates. Secant of theta is the same as the reciprocal of cosine of theta. R equals negative 3 over cosine of theta. We multiply both sides by cosine of theta to get r cosine of theta equals negative 3. And r cosine of theta is x. So our answer, x equals negative 3. It is a straight line. We use the graphing calculator to help us check the answer. Click on Mode. Select POL. Click on y equals. Type in negative 3 divided by cosine of theta. Click on Window. We will change x mean to negative 5 and x max to 1. And we change y mean to negative 3 and y max to 3. That's good enough. We click on Graph. We have this line here. X equals negative 3, the same as what we got. We will convert the equation r equals 1 plus sine of theta into rectangular coordinates. We subtract sine of theta from both sides of the equation first. R minus sine of theta equals 1. Then we multiply the whole equation by r. We get r squared minus r sine of theta equals r. Now r is a little bit difficult to handle. We have in our equation from the theorem r squared equals x squared plus y squared. So we will square both sides of the equation. We get parentheses r squared minus r sine of theta, close parentheses, and then squared equals r squared. We can substitute r squared by x squared plus y squared and r sine theta by y. Then our answer is x squared plus y squared minus y all squared equals x squared plus y squared.